Hi construction materials and detail students. This again is Detail Detectives. So as you know, when we had lectures before COVID-19, we would cover concepts briefly in class and then come out on campus and draw details of elements constructed on campus. The way that we would do this is we would look for clues to how things were constructed. So with retaining walls, drainage is always a big clue. Drainage behind a retaining wall helps to relieve this hydrostatic pressure that builds up. So what happens is you have water that's moving through the soil, and when it hits the retaining wall, unless there's adequate drainage, there's nowhere for the water to go. And so what happens is it builds up this pressure, this hydrostatic pressure. And if it's not relieved, it's relieved through proper drainage, but if it's not relieved, then it can cause wall failure. And in this retaining wall here, we can see the failure from the hydrostatic pressure built up over time without adequate drainage to relieve that pressure. So this is a really great shot. You can see how the wall bows forward, right? And so that's what happens with hydrostatic pressure over time. It causes wall failure. In this case, it pushed it forward. All right, we saw how, from the previous angle, we saw how the wall has bowed forward. But now look at this massive crack that goes from the entire length of the wall, right? And then there's a similar crack on the other side. I don't know if we can zoom in to see that, right? So this wall is obvious, right? From these clues, the wall bowing forward, the wall cracking through the entire height of the wall, it's obvious that it was not constructed with adequate drainage behind it to relieve that hydrostatic pressure. Also take a look at the brick pattern. So overall, it's a running bond pattern with a brick roll lock at the top, but then we have these accent rows. The other thing that's really egregious about this wall is the way that they tapered the brick down. Oh my goodness, look at that. So they have, they have this rectangular building unit, and then they have this sloping down. And so instead of cutting the brick or stepping the sides down, they just filled in the gaps with concrete or mortar. Which, oh my goodness, that looks terrible. And look, you can see another crack going through the height of the wall. Okay, lastly, we need to make a determination about the width of the wall. So we see it's 1 brick wide because we see the roll lock cap at the top. On the front of the wall, the facade, we can see brick veneer, and then this glimpse here on the back of the wall, we can also see brick veneer. So I want you to look at these clues and figure out how this wall was constructed. What does the interior of the wall look like? So what I want you to do in this detail, right? I don't want you to draw it how it's installed, because it's not installed properly. And the thing that's so shocking about this wall, the importance of hydrostatic pressure is, look, there's a building right there. Theoretically, it's not, it wouldn't experience a high amount of pressure. But just that amount in a wall that's, not even 3 feet tall has caused major failure. So your challenge, right, in this detail detective is to look for clues to how this wall was poorly constructed and resolve them in a new detail. So in a new detail, I would expect to see a wall that was, around 3 feet tall, like this, a wall that was retaining soil, but a wall that had adequate drainage behind it, right, to relieve that hydrostatic pressure. Then you could also address the issues of the sides. I mean, it's nice for it to slope down with the lawn behind it, but man, filling the gaps with that mortar is terrible. It looks atrocious. So how could you resolve that? You know, and of course there's infinite number of ways to resolve the situation. But in this detail, right, I want you to fix everything that's wrong with this wall. So what I'm looking for is just a section of the tallest part of the wall and how you would address drainage. And then I would like for you to address the slope here, how you can make that a little more graceful. And these are standard size brick.